Thank you very much. We spoke earlier. My name is Reese Richardson. I am here today on behalf of Luis Amaral, who could not make it today. He was my PhD advisor, mentor, and friend. And I am here today to talk to you about paper mills. This presentation is the SparkNotes version of a very dense paper that was just published in PNAS. If you need more details that are lacking here, please refer to the paper or come and find me. So, we took on this study because of the massive gaps in information in our collective knowledge about the wider industry of scientific fraud, with some exceptions, largely due to the dogged efforts of people that you'll be hearing from in this session immediately after me. Um, we know very little about how paper mills operate and how they work, and chief among all uncertainties, we do not know how large the problem is and if the problem may or may not be growing. What we do have is information that people have fought thanklessly to bring to the surface. So with that, we have pub peer comments, we have the Retraction Watch database, and we also collected a aggregate corpus of more than 30,000 papers that have been labeled as suspected paper mill products. And we combine this data. This is an old version of the slides that we're using here, but we combine this data with OpenAlex and indexing data from Scopus and Web of Science and Medline, as well as some digital archaeology to try to see if we could use these surface level indicators, these footprints on the web and in the scientific literature, to try to get at the organizations that are operating beneath the surface. So our case study, our findings are organized into a series of case studies. The first case study has to do with editors. So for this, we use journals that made their editor metadata openly available, and we developed a statistical method that uses a Poisson binomial test to try to flag editors that handled problematic articles much more frequently than you would expect by random chance. What you're seeing here is a network of editors from PLOS One, where a large part of them were in this tightly connected cluster where they were all sending their articles to one another. So we were able to uncover these networks of editorial collusion at PLOS One with this method. And we also found editors at 10 Hindawi journals and applied the same method to IEEE conferences. What you should note here is that this network in particular is incredibly resilient. If PLOS was not as proactive as they are and only found one of these editors and removed them from their position of power, this network could continue unimpeded. You should also note that this paints a picture that is in direct contrast to the talking point from publishers that paper mills are a sort of leakage problem, and that what we really need is more training on the part of editors to recognize them. This points to a picture where, in many cases, editors are complicit in what's going on. The next case study has to do with scale. And for this, we used inter-article duplication of images, which you heard about earlier, a common marker of paper mill provenance. So we trawled all pub peer comments, and we found instances in these comments where people had linked one article to another article by way of a shared image that should not have been shared. And with this, we were able to construct a network of more than 2,000 articles that variously shared images with one another. Each connected component of this network could plausibly have come from the same place. So, with that, we see the massive capability for coordination at scale. And we also look and do some inference on each of these clusters and find that they tend to show up in the same places at the same time, which also speaks to coordination and how these articles actually get published. The third case study has to do with my favorite company on earth, the Academic Research and Development Association, ARDA. ARDAconference.com is where you can find them. They recently sanitized their website, but you can find it on the Wayback Machine. And ARDA acts as a broker organization. If you have a paper that you need to get published, they will connect you with editors in journals that are willing to publish it, no questions asked. And uniquely among these kind of organizations, ARDA actually maintained a list of journals on their website that they operated in. By chance, I happened to look at this list one day and noticed that it had changed from the last time that I had been there. So we used the Internet Archive to reconstruct a timeline of journals and how they operate and how ARDA was moving across them over time. And in fact, their repertoire of journals was growing. This figure is a little hard to interpret, but each line here is a journal, and it extends from the first time it shows up on the website to the last time. And many times, these changes in the journals were uh, probably the result of indexing decisions in Scopus and Web of Science. Basically, a journal would get de-indexed, it would disappear from the website, and then it would be replaced by another Scopus or Web of Science index journal. So this also paints the picture of an organization that is very resilient to adversarial attacks. And I'll note that these adversarial attacks, like de-indexing or retraction, are applied very infrequently. They're often held up as integrity measures in a way to disincentivize people from engaging in problematic behavior. However, when we actually look at the data, you can see that while Web of Science, Scopus, and Medline index thousands or tens of thousands of journals growing every year, they only de-index around 100 journals every year, often less than that. And when you look at our aggregate corpus of paper mill products, which again is not representative, it only represents a small fraction of what is probably out there. Less than 25% of those, which have already received an outsized amount of attention, have or will ever be retracted if we're extrapolating from current trends. So if you run a paper mill, you can largely just avoid these integrity measures by operating a large enough stable of journals and having a large enough network that you can rely on. And you can avoid retractions by only publishing in venues that won't retract your stuff. Uh, the fourth vignette has to do with differential rates of fraud in different fields. I might skip this one for the sake of time, but if you're interested, please let me know during the comments. We also found that retractions now tend to happen mostly in large batches. So I've updated this data from what was shown in the manuscript, but you can see that the majority of retractions now happen on the same day in the same journal as part of a batch of 10 or more articles. Regardless of how you see the integrity problem, it is clear that publishers see the bulk of their integrity problem as large-scale breaches of publication integrity, not single instances where an article is slipping through the cracks. And finally, we wanted to arrive at the roughest of rough, ballparkest of ballpark estimates of what the growth rate of systematic fraud might be in the scientific literature. So we took the corpora that we have, and that's what this figure is showing here. So the year of publication is on the x-axis. The y-axis shows a log scale. So linear in this space represents exponential growth. And we found that while all scientific articles are doubling about every 15 years, this is a trend that has been known since the 60s. Pub peer commented articles and retracted articles are growing every 3 to 4 years, doubling in size and annual volume every 3 to 4 years. Whereas our corpus of selected paper mill of suspected paper mill products was doubling in size every year and a half. So again, this is a small subset of what is probably out there. It is biased by selection. There are definite biases in discipline. There are definite biases in time. But we believe that the other case studies that form this analysis paint a picture of a world where this sort of growth rate is possible. So we frame this all in terms of a public goods game. And that's really what science is. A bunch of people collaborating to contribute to a common good and getting something in return from the gods. What this shows is defection from that game, cheating being a winning strategy. And moreover, that there are large organizations that sustain and profit from mass scale defection. In this environment, even if we believe that systematic fraud is only a small fraction of what's out there in the literature, we can only expect strong growth in this industry in the future. And we're going to need a lot more research to get to more precise answers. To that end, I hope that this study has made it marginally easier to address systematic fraud as a legitimate object of metascientific inquiry. And I should also note that these trends are largely due to the inequality and hyper competition in the scientific enterprise, which is only going to get worse as a result of the cuts of the right-wing government in charge of the United States right now. Um, and finally, I wanted to emphasize that we could only use the information that is actually out there. If that information is not shared by publishers like PLOS or like Wiley, we cannot use it. So we need more buy-in from people to share publication metadata. With that, I didn't get the chance to thank everybody who has been fighting to show that paper mills are a real and serious threat to the scientific literature and to scientific communities. And I also wanted to direct you to the collection of open science integrity guides. This is an open source handbook that I have the pleasure of being one of the maintainers for doing post-publication peer review. If you're interested in better characterizing paper mills, I highly encourage you to check it out, and there is an open invitation to contribute. With that, I will take any questions.
Steve Finn, University of Washington, JAMA Network. Fascinating. To what extent do you think journals need to better vet their editors? Because it sounds from your description that they are complicit in these networks.
That's exactly how I would describe it. Journals do need to put a large amount of resources into vetting the people that, let's face it, they outsource a lot of work to. In the same way that you would vet a hire, you need to be vetting the sort of the gatekeepers of the scientific literature, right? Because there's a strong possibility for abuse.
Hi, here's Veronique Kiermer with PLOS. Thanks for your study. It's a super important study, and I'm actually very happy that you could use our data to do this.
Yes, thank you. Pass my thanks along to the people maintaining that data because it is phenomenally useful.
We do need these studies, and as you said, it's important that we provide the data that allows this research to be done. Is there any additional types of data that you would find particularly useful that you've run across the things? Because what I really want to do here, there are enough publishers in the room that I think we all need to be very much more open about the data that we make public for this kind of research. This study has shown that we had already addressed a number of the issues, but not all of them. And so we need more tools to do this kind of thing. So it's a call to meta-researchers here to actually tell us what you need to see in terms of transparent data from publishers, and a call to publishers to actually try to make efforts in that direction.
I agree precisely. And yeah, we can clap for that. That's salient point. Set of salient points. The need for tools is a large impetus for why we developed COSIG. That's one. As for the sorts of metadata that can be available, publishers should consult the metadata that PLOS makes available because it is everything. Even if you're not an open access publisher and your content is under copyright and you can't share the content, there's oodles of metadata that you could be sharing that could be useful for people that is not behind a paywall. And it is much easier to just have people download that and, let's face it, do the integrity work for you in many instances than to rely on people scraping your data piecemeal or not be able to work with that data at all.
Hi, Reese. Tim Kershaw, Spring in Nature. Thanks for your great paper. I was wondering about your assessment of one of the data sources. You've relied on the Retraction Watch database. We know that the Retraction Watch database classifies certain retractions as resulting of misconduct in paper mill. What's your confidence in the reliability of that classification, knowing that many publishers won't literally say in a retraction notice, this article is a paper mill article, therefore we are retracting it?
Honestly, not great. You know, you're absolutely right that retraction notices are notoriously opaque. And I know that labels in the retraction watch data can also be applied somewhat inconsistently. I spoke earlier about the value of sort of weak indicators that something might be going on. So I hope that in that corpus, among the many corpora that make up our aggregate corpus of suspected paper mill products, that at least numerically it's representative. But you're right.
Thanks.
Thank you.
Thanks, David and Reese. A question from Kathy Zeller at the BU University School of Law, asking if you have advice for others who'd like to publish this sort of work, given resistance from editors to airing this kind of information.
Oh boy, there are some veterans of this work in the room. Not to put Anna on the spot. Well, she's going to be up here anyway, but like Anna, I'm sure can offer some advice on this as well as Elizabeth and other people that do this work and report to publishers and routinely interact with editors. There is no secret sauce. It took a lot of persistence, and we faced a lot of pushback, even in the final stages as we were sharing our findings. We faced a lot of pressure to moderate our language. Not all of it was entirely unjustified, and I think we have a better paper as a result, but this is an incredibly sensitive topic. So it requires rigor, but it also requires not giving up on it. That's about the best that I can offer. But thank you for that question.
Johnny Anidi, Stanford. It's really a great study. When you say that the paper mills are outnumbering the pub peer and efforts to try to track, I think the gap is even bigger because pub peer probably 1 out of 10 comments is really detecting a major problem that like a paper mill, something to be retracted. In fact, I'm wondering whether by looking at these data sets, you could set some estimate of how informative comments are currently in pub peer. In the past, we used to say about 50% may herald a retraction or a serious problem. Based on what I see now, I think that percentage has decreased. In a way, it's more used, but probably more used in a more incidental way. The second observation is that you showed that with the batch retractions, the single paper retractions seem to be going down, even pretty sharply. And I do worry that these are really the most important retractions because most of the batch retractions usually are papers that nobody reads, nobody cares, nobody cites, with some exceptions. And they live there to promote their authors in some way in usually corrupt environments. But the single retractions, I think, are more likely to be papers that are very influential, central, really affect scientific fields. And personally, and asking many other people in the field, I see increasing resistance to not retract, but even correct this type of paper. It is somehow, you may spend months and years with the authors and the editors, and they will say, oh, yes, you're correct, we're wrong, but it's okay, let's move on. Do you think that that's a problem?
Yeah, so I'll let your first point about pub peer stand on its own because I think you're absolutely right there. As for the batch retractions, this is going to take further analysis. Whether or not it is actually, I'll go back to that slide, whether or not it's actually decreasing in prevalence might be an issue with how the retraction watch data in recent months is collected. So there could be sort of right censoring there specifically for the single retractions. But I would actually take a differing viewpoint on which of these should be most alarming. I think that these large batch retractions where people are using them to propel their careers and are indeed training others within their professional environments that this is standard publication practice is the gravest threat that we have, regardless of whether these articles are cited in our highly influential circles or in the scientific powerhouses of North America and Europe. They have immense influence in the context in which they're published. Thank you.
Excuse me, Eric Turner with Oregon Health Science University. This might be outside the scope of your talk, but in relation to the paper mills, I guess I'd be interested in hearing more about the incentives, like what's driving this, might help inform future research questions.
The same. So I'd just like to follow up on that also. I think we do have to look at what is driving the fact that articles are increasingly becoming a currency, leading to corrupt systems and
not just corrupt individuals. So sure.
Absolutely. I'll take 30 seconds on that. So we live in a hyper-competitive and highly unequal scientific enterprise, and we believe that paper mills are most likely to find purchase in environments where the pressure to publish is great and there is high economic interest in appearing to be scientifically productive, but the resources to do genuine science are scarce. If you're in a low-resource context and your employer is requiring you to publish, but you don't have the staff, you don't have the funding, you don't have the time to do it, you're faced with a position where you either have to engage in this behavior, which you may or may not regard as wrong and you may indeed regard as normative, or leave science. I'm not sure what I would do in such a situation. And I think we really need to be cognizant of that human factor. So I'll echo both of your points there. But thank you so much.